Hello, Frank. Thanks for thanks
Hey,
for joining.
welcome. How you doing?
I'm doing good. Today is pretty non-sunny day, so
Yeah,
it's not kind of not usual in Texas. What about you?
same here. Not that sunny. All the light you see is actually artificial. It's already dark and it's raining. But that's
But that
that's rare conditions in Munich. Normally we have great weather here.
but that's Deutschland. It kind of should be like this, right?
Yeah, right. Well, I origin from the northern part of Germany. I'm really used to a lot of muddy weather. Um, Weather in Munich compared to this is way better, way better.
Because Munich is south, right?
Yeah, right.
Great. So let me start. Could you introduce yourself and what do you do?
Okay, yeah, hi, I'm Frank, software developer, consultant, and the boss of everything in Dev for Agriculture. We do software development specifically for agriculture, so for the data exchange between farm management systems and agricultural machinery. Doing this since 2018, and yeah.
Yeah. Could you explain your business if I were like 5 years old, if I were kind of young kid, and so just from complete outsider to understand your business sort of from higher perspective, and then kind of go lower and lower.
Yeah, of course. Well, imagine you are a farmer and you have a farm and you have a lot of machinery out there. During all your day work, there's a lot of stuff that you have to document. For example, you have to document your fuel consumption. You want to know what's coming from your field. You want to know what's going to your field. You also have to document this. And well, there's two ways of doing it. One way would be you sit down in the evening and type everything by hand, or you can do it automated. If you want to do it automated, you take a farm management system, and such a farm management system, there are various farm management systems on the market that can help you in your documentation. There is software that is specialized for vineyards, there's software specialized for horticulture, software specialized for aerial agriculture. And so they are very specialized in their specific areas for the farmer. But the reading or the communication with machinery, which would be the second way of doing it, getting all the data automated from your machinery so you don't have to type everything, you only have to check if it's all like you want it to be. This data exchange is on the one hand standardized, but on the other hand can be very complicated. So we thought it makes sense that not every single farm management system has the burden of working with this stuff and reading into the ISO standard, reading into the AgriRouter or John Deere or whatever API specification. And so we provide services for farm
Sort of
management
interruption.
systems. Yeah,
It's the thing that you mentioned, that you have different like tractors, different machines, and sometimes it's kind of they have all the different internal systems, and it's quite hard to connect everything in one kind of integrated infrastructure, right?
yeah, correct. You have, on the one hand, you have the infrastructure on the field. That's what farmers know as isobus. So you plug your seeder into your tractor, and then the terminal on the tractor directly shows you, okay, this is a seeder from, let's say, Amazon or from Lemken, and this is how it's currently seeding. Here you see the amount per area. Here you see the amount on the left part of the machine, on the right part of the machine, and so on and so on. And if you detach the seeder and put on a fertilizer, then you see, okay, now it's my Rauch fertilizer and it can fertilize this amount and so on and so on. So it's very flexible depending on which machine you put behind the tractor. That's the infrastructure on the field, and then you have the infrastructure for the whole farm, which includes the farmer's laptop and the connection between machines that are not physically connected. Imagine, for example, you have a harvesting machine. It cuts the corn, and it cannot collect it because it doesn't have such a huge bunker to collect the whole field. So you would have tractors, or in the US mostly trucks, that receive all the corn from the harvester. And so you have a connection between those two that is not physical, but that is needed in a harvesting chain. So that the truck driver knows where the chopper driver is, that the driver of the fuel truck knows when to fuel up the chopper and all that stuff. So that's the second layer of the infrastructure. And that's the area where we work in.
It's sort of like kind of intercepts with this idea of IoT and when everything is kind of connected into one infrastructure, and probably the more data you have, the better system you can build, the more efficient with less, when you basically lose the efficiency because you don't have some data in it. So, for example, probably you are installing all the data gathering devices that kind of get data from all these inputs, and then you combine it, right?
Well, yeah, you can combine it with kind of a sensor fusion. For example, we currently worked on something where we can say, okay, the truck is near the chopper, and now it's coming near the chopper. It's been with the chopper for a while. Now it's leaving the chopper. Both are on this one field. And if this truck reaches a scale, we know, okay, this truck is from this field together with this chopper. So whatever we weigh on the scale will be from this field. This is just one example. What you always have to keep in mind is that more data is not always better. You can get lost.
Oh, really?
Yeah, you can get lost if you have too many information. You have to focus on what you really need. But then on the other hand, depending on the use case, there might be different information that you might need. So looking into the data and say like, hey, we have 1 billion data points doesn't help you anything if the relevant data points is like 100 or something like that.
Okay.
So, watch out with
that. Yeah, go ahead. Yeah.
I just wanted to say, watch out with the face bumps. I did that in the past and didn't work out too good.
Well, I'm also, you see, like I used to have like hairline really great, but right now you see it's receding. So kind of like soon I will be in the club, you know?
Yeah.
So I thought that the more data, the better. Kind of like with AI, you know, the more data you go, you feed to the algorithm, the more data on the output you have. But you see, in IoT, it's kind of not the case, right?
Well, it's, as I would say, with AI, it's the same. If you want to train, for example, if you want to train the Copilot from GitHub, then it doesn't really help you to know a lot about plants or a lot about, I don't know, balloons or whatever. So information that's not relevant for your use case, you know? And that's the same with agriculture. You have different use cases. For example, the fuel consumption is quite important for you for the documentation, but it's not really important, or in most cases, not really important for the agricultural process. I mean, of course, if you see that you lose a lot of fuel while you're on the field, that's important for the agriculture quality, for the plant quality. But putting that aside, this would be information that you might not really need. But on the other hand, the fuel consumption while plowing can tell you which kind of soil you have and how to handle the plants on the soil, seeding, fertilizing, and so on.
Yeah. So as we touch AI, I wanted to ask you if you use AI, or do you have plans for using AI to kind of improve all the system functioning?
So when we talk about you, so me, I already use API, the most simple version like ChatGPT and Copilot during development, because it really cuts down the handwork for stuff like, hey, I have my database structure here, and I would like to create just an API reader that reads data from the database and provides it to the network. Yeah. Of course, you cannot just say, I want the fixed software with all the permissions and so on, but the base is quite good. It's kind of the same, like you use you can use Stack Overflow for the good, reading, understanding, and fixing your bug, or you can use it for the bad, like reading, copy paste into your code and say you're done. I would not say let's do the second one, but for the first thing, it can really help you. It's kind of like a beginner junior developer.
or if you're using like a lot of different classes in .NET, right, and it helps you to kind of spare your time from typing like boop, 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 all these pretty standard lines of code, and it just saves time, right?
Yeah, right. And conversion, if you say you have a backend in C# and your front end is in JavaScript, to say, hey, this is my backend classes, just do a quick conversion from this to JavaScript or TypeScript. We work with TypeScript in the front end more. That really speeds stuff up. So, but I think your question was going more towards products in agriculture.
I mean, obviously it's interconnected, right? Because if you use code and AI in code, it's kind of also connected. But my question was if you directly use AI into your infrastructure. Like, for example, like just out of the blue, I'm thinking that there should be some kind of frameworks that like, or if there are not such things, they should be in the future, where you can feed it standard data that is collected on the field, and then it could give you some outputs. Like, for example, like you're losing like some efficiency because of moisture levels in your crop or something. So it could be used in this way. It's my opinion. What do you think?
Yeah, I agree. I have to admit that I'm not really an AI expert. Let's say I know the uppest level, like using ChatGPT, and I understand the lowest level of like what a neural network is. But the part in between, how to train it, in the middle, how to train it and stuff like that, I'm not really an expert. Therefore, we currently in Dev Agriculture don't have any products so far in that use artificial intelligence. But in agriculture, it's getting more and more, starting from simple advisors like really a chat GPT for the farmer, where you can say, hey, I seeded this type of corn and now the plant looks like that. What should I do? The most common use case, or the two most common use cases with artificial intelligence, is the automatic recognition of a plant disease. So you have cameras you have sprayers, and you have cameras on the sprayer. They look onto the crop like 2 meters in front of your boom. So the boom is this sprayer arm. And on the fly, they recognize that there is a bad plant that has to go away, and then they can spray. There's a lot of robots out there that do the same in slower version. And they have different ways of handling the bad plants. Some spray, some take hot water, some take lasers, and some just stamp it out with a strong piece of metal. That's what's really used in agriculture. And the second part is AI towards processing satellite images. You know, we have those satellites in the air that read data, or that that collect light in different frequencies. Not only red, green, blue, but also the infrared area and stuff like that. And that look from the sky onto the whole Earth. And you can take those information. They are in Europe, more or less freely available. It's the Sentinel-2 project. That's European, I think, an ESA project. And from this data, you can calculate, okay, where should I fertilize more? Where should I seed with more density and less density? And where are my fields in general? So they, just from the normal picture, they can say, okay, this is a field boundary, and there is where a street starts, this is where trees are, and so on. Automatically generating data to control the machine. It's not live control, but it's like you create a prescription and then you tell that to the machine.
Sounds really great. So basically, it looks for kind of color discrepancy where like some crops are maybe too green or too yellow, and it looks where should you put your efforts into, right?
Yeah, correct. I've also seen some videos of where they tried to improve the resolution. Normally you have a resolution of I think 10 by 10 meters, and they were able to increase the resolution. Like I don't know if you know this from CSI whatever, where they have like this very bloody bad image of a surveillance camera and say like, okay, we need to know the license plate, and then they just
Yeah.
do whoop, and here is the license plate. So
Yeah, yeah,
something
yeah.
like that, but at least they say it works. I didn't test that yet,
Wow, wow.
but I saw it, and it's going this way because if you know which kind of plant it is, you can like recreate the structure.
And do you also
And
use this data from the satellites in depth for
yes,
agriculture, right?
Yes,
Yeah,
we use the data,
yeah.
we convert the data. So you receive the data, then you have those experts who really say fertilize this, seed this, and please
Uh-huh.
seed this amount. And then you have the data in the format of those experts, and we convert it so that the tractor can read it.
So it's kind of like a combination of human and AI. AI is saying, hey
Yeah,
guys,
yeah, yeah,
there are like 10, there is for your crop, there are like 10 places where it may be something wrong with it. And basically then human
yeah,
manually check it and they say, hey, yes, you can do it, right?
yeah,
That
absolutely.
sounds really great. Yeah. Yeah.
Absolutely. It's always like a combination. The human trains the AI informs the human, and then the human trains again. A good example, I told about the satellite images that shows you areas of different types of soil. And then you want to be more precise, so you go down to the field and really do soil sampling. So you stick your fork, not fork, spoon. I'm missing a word here, the big spoon
Big
into
spoon,
the
yeah.
field
Kind
and
of
collect
like
a sample.
shovel, right?
Shovel. Yeah, right. Sorry, not a native speaker.
Yeah.
You take a shovel, dig and get a small sample that you would send to a laboratory. So the
Yeah.
laboratory can take a look and can give you way more information about your soil than the satellites can. But
Of course, of course, of course.
the satellites can help you to tell, okay, you have 3 areas in the field, and if you want to do like 15 samples, then you should do 5 samples here, 5 samples here, 5 samples here, because otherwise it might happen that you take 12 samples in just one type of soil where you will always get the same results, and then 3 samples distributed between the other 2 areas. And so this can help you as well.
Yeah, and basically it's first time because if you manually try to go over and look and go over and try every part by shovel, it will take like forever, right? A lot of
Yeah,
time, so it's almost
and
impossible.
it costs a lot of money. It costs a lot of
Yes,
money
yes,
because
yes. So basically, it's like ChatGPT, right? Combination of human and AI.
yeah, right.
Because
And
you can say into ChatGPT like, hey, write me this program. You can ask some classes and then you have to manually check them. And if they are right, if they
yeah,
work really great, you can install them into a program. The same with agriculture, right?
yeah, right. But you definitely need an expert to review the data. It's the same with ChatGPT. If you set someone who cannot code to ChatGPT and ask him to build an application, he will get lost. Even if he knew what he would have to ask. If there's a little tiny wrong question or a little tiny wrong word in your question, then that thing will do something very different. And you and me as developers, we see that. A non-developer would not see that and would get lost at that part. So
Yeah.
maybe after like 2 months of asking back and forth, he would fix it by luck. But yeah, and it's the same with agriculture. So if I, as a coder but not farmer, would ask, here is my soil samples, please tell me something about the ingredients like phosphor, raw ashes, and so on, and that thing would tell me something. I could trust it, I could not trust it, but I would have not that many ideas of, well, is this reasonable what the system is telling me?
It's interesting that you mentioned like combination of coding and farmers, kind of quite different domains. Usually, it's sometimes considered kind of not cool to go into agriculture. You're like coder, you want to make all this like fancy AI stuff, and agriculture seems to be like more traditional field, And so it's
I have to interrupt you there. Agriculture is a super cool field. I mean, you're out in the field all the day with those huge machines. I mean, that's cool.
Yes,
that's really cool.
with this that you told me, it's like modern warfare or something, like satellites from here, computer vision. Basically, we're one step away from AI capturing like humanity because of agriculture. Like you see, this like computer vision from the up
from satellites, space,
and you have computer vision from the tractor. So basically, the machine ruling could start from agriculture stuff,
Yeah, hopefully not. But, well, yeah,
I wanted to ask you about some fun like stories in your business, maybe like with computer vision or satellites, or in general some fun stuff where technology works not as it's supposed to be working.
Wow, you have to cut the break out. You have to cut this break out.
I will.
Yeah. And I will think a bit longer so that you can find this area because it's bigger.
So let me make my haircut meanwhile.
Well, we had. I once saw a bucket. It never reached the outer world. Let's say it like this. It was a testing software, but we had a yield measurement system, and this yield measurement system, a test customer complained that the data is wrong. He called us in the afternoon and said the data is wrong, and so we said like, okay, we're gonna test it tomorrow. So we sat there morning, tested, everything's fine. Said, hey, everything's fine, and he called us in the afternoon again, and no, it's broken, and we tested it in the morning, and it was all fine.
Mm-hmm.
He called in the afternoon, no. Yes, no, yes, no, yes. So in the end, it turned out, in the machine, you have different ECUs, so different computers, they communicate with each other. And there was one computer that communicated only two information. Number one was the total yield, and number two was a timestamp. And these two information were sent in two messages. And the messages were marked by a specific identifier. And this identifier, the receiving computer, ignored that. In the morning, the timestamp was so small that it didn't really make any difference. But in the afternoon, we had an overflow into this one bit and had like 100 times the amount. And
wow.
That's like bugs where you really have to search for a while if it's a black box. But yeah, we were lucky to find it before it reached the market. So
it'll be funny, like, hey guys, our software works in the mornings, but not in the afternoons.
Yeah, correct. We are working for you so that you don't have to work over hours. Start in the morning and you will be done on time. Or you will have to be done on time. Yeah. Yeah. That's one thing. I mean, I don't know if even to call it, it was not like funny because everything was broke, but I keep on telling about the story when I really started at the machine manufacturer where I used to work for. That was back in 2010. I went there for my bachelor's thesis, and when I visited a driver first year, it took me 20 minutes to be able to say hello. the driver of the chopper, because he was always just like calling, yeah, I'm on this field. Yes, boss, the current total yield is blah, blah, blah. And no, I already left this field. And hey, where are you staying? I'm running out of trucks.
Wow.
And like,
what year?
that was
What year
210.
was it?
That was 2.9 or 2.10. Don't, yeah. It was 2.9 or 2.10. However, 1 year later, I visited that guy again, and we had a great conversation. I entered the cab, I said, hi, how are you doing? And he was working. The change was very small, but for him was very big. Everyone had a smartphone, and we just exchanged positions. Super simple fleet management, super simple solution, but it really helped. You know, when I started with this manufacturer, they used to navigate with I'm not sure how you call this in English. Those triangles with a warning sign that you have in your car in case of your car breaks down, that you have to put down on the street to warn other people.
Let's say some warning stuff.
Yeah, so some warning triangle, and they used to work like they had hundreds of those triangles. And the route planning was like, okay, I put one on the left side of the road, then you have to turn left. I put one on the right side of the road, then you have to turn right. And that's how they navigated, how they found their fields back then.
Wow.
So,
it's crazy.
But it's been 14 years ago, so we've reached way better situations here.
And it was pretty easy to fix, right? When you just put it like navigation, and it showed like not very accurate, but still kind of you can find the route how to go, right? Instead of using these triangles. Warning triangles.
Yeah, it's at the beginning, it's really the low hanging fruits, very small changes that you do that gives you a big.
Return on investment.
Big win. Yeah. Big return on invest. And then you start to collect all these small wins. And then there's this one last stumble stone. If you kick this one over, then everything will make sense. Everything will work. For example, if you have a simple sensor that just says my machine is working or not working, what does that help you to say something is turning or not?
Yeah.
But if you combine this with, I know it is a swather, so the one that, or rake, I think rake is a word in English, you rake the grass together on a pile. You can, if you connect it with this one and then connect this sensor that just says the thing is active or not, connect it to the cloud, and you have the information about the field. Then you know, how long have I worked on the field? How much area did I do? I can plan my machine maintenance because the swather has been working for a while, and I can automatically inform the baler or the chopper, whoever comes after the swather, to say, hey, I'm done with this field, you can work here now. I can document the work and the working time. And with that, I have this small sensor, but a huge step forward so that I could nearly automate everything. Does not yet work because we have other small stumble stones, but that's like you put this one in place, then you put this one in place, and you put this last one in place, and it's like small change, big win.
Yeah, it's sort of like I don't know if you read this book. It's called Atomic Habits by I don't remember author, and he said that like he mentioned the example of English cycling team. They always suck, like historically, and then there was one coach, and he started to improve some small stuff, like a little bit here, a little bit there, like small fixes, and then eventually it's kind of it becomes huge snowball, and it's really
correct. It's like if you have like, if you say, hey, I have one sensor that can document one information, and still I sit on the laptop and have to type 180 other information. I can type 181. But if you have the sensor, then you maybe have the sensor 20 times and it's only 160. Still, you can type it, and so on and so on. And then sooner or later, you recognize some information, rely on the other information. So once you say, I have the sensor and I know on which field that thing was, I can also document, okay, this field has been working. So I can forward my planning and automatically plan, okay, I worked on that field, and from now I always say like 1 week forward, I do the next thing, I do like seeding, something like that. And if I see, I have to seed, then I would say, okay, please create me an application map, which is always like the same 3 to 4 clicks. And then I have this application map to review, and I say, okay, that's okay. If I can move away all that stuff before, because I automatically documented, I've been on this field, I've worked on this field. So it says the trigger, like in 1 week, here's your application map, what is wrong? So I don't have to ask for the map, it automatically comes to me, and I only have to say what is wrong. This is wrong, this is wrong, this is wrong, click, and then it directly goes to the machine, compared to, oh yeah, this is my map, now I have to download it, I have to put it on my USB stick, where's my USB stick? Okay, here it is. Driver, please put it into the tractor. Driver puts it into his pocket, gets on the tractor. Oh shit, where's the USB stick? Compared to connected via cloud, it's there. And that's those small things. It's not like rocket science. It's not really a rocket science here. It's just a combination of the small stuff. Sensor fusion.
And basically it gives you the like all this like one integrated infrastructure where like you have everything in one place, and you can like see and kind of like sort of like that the idea of dashboard where you have like one thing you can see like, hey, where are we losing our and also it kind of helps you to install new things because you see like the places where you don't have enough data, right? And you think, maybe I can install some other like sensor or some other data collector stuff. I don't know, something to get data from and to have more data to make right some improvements, right?
Yeah, and the question, do I even need this information? It's always a very important topic. Like, I've always documented that down. Do I really need that? I mean, a lot of the documentation that farmers do is mandatory for the subsidies. Subsidies, I think is the word, that they receive specifically here in the European Union. But a lot of stuff this, we've always done it like that. And then it's always good to go one step back and say, do I really need that? And then you can either eliminate or automate it.
Oh, wow. So do you often, like, how often do you eliminate some unnecessary data?
Good question. As I'm more the second level and not the farm management system, I don't personally eliminate that much data with a customer. But I often have discussions with my customers if they say, yeah, we want to integrate data. And the first thing they always want is, we want a map that displays the data. And I say like, okay, what is the data? Yeah, like everything. Okay, so you want to display the fuel consumption on this part of the field? No, why should we do that? So if they don't have a use case, I can say like, okay, don't get lost in this amount of data. Show the farmer what he really needs, and then we can always extend it. But that's like the part that you have to take a look at, because it's not that we have too little information in the world. We have too many information in the world. And so we have to help the people to filter for the information they really need. Of course, I cannot say like, this is something someone needs or this is something someone doesn't need. But I can say this is something someone needs if his focus is on this and this topic. So, for example, if I want to organize machinery, then of course the information of fuel consumption is important. If I want to maintain the engine even, then of course fuel consumption over time with workload and so on can be interesting and important to optimize the engine. But if I say like, I want to know how much I harvested, I don't give up about fuel consumption at that part. So
You see, usually people are kind of reluctant to remove the data that they have. They think, maybe in the future it would be helpful, and I removed it. And so usually we are
yeah,
quite eager to add something new, but we are really reluctant to remove. But actually, that's the problem, because we're kind of getting stuck into all this ocean of unnecessary data, and we
yeah.
can't see the important things, while getting lost into like all these unnecessary details that basically it's a noise, like noise and idea, noise and
Mm,
signal. Basically,
yeah.
almost like this like concept also like 80-20. Almost all the data is like kind of noise, and to find signal is quite hard. Moreover, it's even more hard when sometimes this data used to be really helpful, and it's not very helpful anymore, and you kind of getting stuck to your
Yeah.
past decisions. And
Yeah. I mean, the let's say the cost of collecting data, specifically machine data, is not that high. So if you just collect it and it is in your database so that it doesn't get lost, that's okay. But the difference, the abstraction has to be made when you show it to the user to tell the user, hey, do you really need all of this, or would you really like to focus on something? But one thing you have to keep in mind is if you just collect data without doing anything with it, you also don't check the quality really. So it might be that you collect data for, let's say you collect data of fuel consumption for 6 years, and then you want to run a test based on the fuel consumption, and you want to train your, let's say, again, AI model with the fuel consumption data of the last 5 years. But if you've never taken a look at those data, maybe it's broken and you collected data for 5 years for nothing. So
yeah, and
that's the
yes,
other
it's like
side of the medal. So
yeah, you see, you have to follow. Wow, you have to follow really closely to the quality of the information that you gather, and also you have all the data. And as user, you are kind of dispersing your focus. You are thinking not about important stuff, but kind of all these kind of unnecessary distractions. Yes.
yeah,
Okay. Okay. Cool. So probably we will finish soon. Yeah. So you wanted to add something, some maybe like less ideas or thoughts.
yeah. You talked about this all-in-one solution infrastructure that you said. It's
Yeah.
a topic of interoperability. The idea, I mean, as an IT guy, of course, I would like to say we have this one solution dashboard, and of course, as a businessman, I would like to say it's mine, but it's not realistic because agriculture is different in different areas of the world, in different business areas, and so on and so on. And it's important to have multiple players in the market. So if the interoperability, so that's the small machine manufacturers who are, for example, really specialized in fertilizing, that they can play with those guys who are able to build tractors. And that those guys are not getting lost by, well, you can work with a machine, but you can't really handle the data because the connection to the cloud is only in the tractor, and the farmer only uses the cloud system of the tractor manufacturer. This, from my point of view, is quite a threat because, well, the bigger the big ones get, and the more you kick out the small ones, the less interest for the big ones exists to build good machines and do the best for the industry. Currently,
Like that.
I think we are
Yeah.
at a good shape. And for example, Isobus has been a really good help for that. So you can connect a baler from Krone to a tractor from Fendt or Same Deutzfahr or John Deere or Case or Claas. That works just fine. Sending data to cloud systems and forwarding, we have some steps to do there.
Okay. Okay. Yeah. So otherwise, you're ending up in a situation like Microsoft is dominating the computer world, and
Yeah.
operational systems, and it's kind of not cool for the industry in general.
Yeah, yeah, correct, correct. Um, let's say it like this: the the internet is quite a good example of how it can work because we have a lot of open standards. Everyone can
Mm-hmm.
access the information. So if you want, you can
Mm-hmm.
sit down in the evening and just write a small software with an HTTP server or something like that. In agriculture, we are trying to make stuff more open. There are open source libraries now for isobus, and we've created open source libraries for ISOXML. This is this data format that you put into the terminals. But having information openly available, technological information, my goodness, this is very important because this helps everyone to participate. It makes the market bigger, and it also gives the opportunity for everyone to invite new functionalities via sensor fusion, for example. So, like if you say I as I said with the soil, uh, I would never have thought about that you can take fuel consumption and define the type of soil based on that. There was a farmer who told me
Mm-hmm.
that when we were discussing about ISO and stuff like that needs open standards, because if you can only talk to like a product manager and he says like, yeah, we can put it on our roadmap for 2040, that doesn't really help.
It's kind of like open source software in the agriculture.
Yeah,
You see,
correct.
I really like, as an outsider, I always thought that agriculture is pretty like centralized. All this government like standards and government help, like financial help. I always thought it's kind of more like a centralized, always like
Mhm.
from top to bottom sort of thing.
Well,
And you were saying basically it's like open source. It's kind of like Linux or something. That's for me. That's like mind blowing
we're,
information.
we're, we're get, we have to get there. Don't get me wrong. We are not yet there. We have to get there. So from the governance perspective, top down, the legal aspects, of course, but the technological aspects. I can give you an example. In Germany, we have 16 different states, and there are, I think, 14 different formats to upload field boundaries to the different states, because two or three states have one format in common, and the others have like, yeah, we did something different, because in Germany it's all distributed between the different states. So the different states had different software providers who created the portals to organize the field boundaries and stuff like that. And there's no real standard on there. On the other hand, the industry with isobus has created a standard everyone is working on. And
Mm-hmm.
yeah,
Wow, really like. I mean, it's maybe that's why you have all these robots that use computer vision and satellites, because it's like kind of
yeah,
gives the opportunity to small players to make some impact and to do something with all the standards, and not to kind of obey by the monopoly rules and be a just uh,
yeah.
just I would say a participant, but without the opportunity to actually impact, to influence the process, and to make like new technology that can combine all the standards.
Well, that's why we need stuff more open. Yeah. And one last thing, we talk about these robots and satellite imagery. We
Mm-hmm.
love those robots. Everyone loves those robots. But I think for a farmer, if you ask him, what do you want to get rid of, driving your tractor or sitting in your office? I think he wants to keep his tractor. Of course, labor shortage. So the more you are a businessman and really focusing on business, and your farm is so big that it's really just a business, then the office part becomes important to you. But if you're really, really close to your farm, to your nature, to your animals, people have different people have different focus. Some like to focus on their farm, like the soil. Some like to focus on the machinery because they really love machines. Some like to focus on the animals, and some, if they would have more free time, would like to focus having more free time with their family and children. And forgot the most important ones, some trying to grow your business. But I think no one would love to use his free time to sit in front of the computer and type in numbers just for the use of typing in numbers. My goal is more or less, it's a long way, but my goal would be to giving the farmer back 2 days a month that he can use for whatever. And that's why we need automation in this infrastructure and farm management systems, independent of the robots.
Like historically, we're agricultural civilization, and it's not common for us to sit in front of computer and to type something. And that's really like, if our ancestors were to observe our way of life, they would say like, hey, look at these losers. I mean, sitting every day like doing stuff on their computer. That's crazy for them, you know.
Yeah.
And so, like, I think like we have like two things to connect to our roots. First, it's sex. Second one is agriculture, you know, where we like can do something with our hands and stuff. So basically, it would be really sad if technology would get rid of
both of it.
And basically, it's happening, you know. I've seen like all these AI generated images, and they look pretty impressive, you know. And so
you're talking about agriculture here, right? I got you.
I'm talking about agriculture. Yes, it's quite interesting how technology, you know, removes people from their roots. Sometimes it helps. Sometimes it really makes things quite unnatural, right, for us.
Yeah, we developed technology to get people away from their roots, and now we try to automate technology to get people back to the roots, to be able to get them back there.
Or kind of make the roots more enhanced, you know.
or this. Yeah. I think we're stumbling forward, upward, and sometimes we have good inventions, sometimes we have bad inventions, but well, the bad stuff will not last forever, and in the end we will reach something.
Yes. Okay, Frank, danke schön for coming, danke schön for joining. It was really great conversation. It was really fun, great experience. Yeah. So maybe we'll make another version of it in the future. Thank you for joining.
Yeah, perfect. Looking forward to that. Thank you that I'm allowed to be your first interview partner, and it was my first interview ever, so hopefully
great.
Hopefully it was
like
okay.
Yeah, it was our first time, right? Yeah.
All right. Then
great.
Thanks a lot. And
thank you,
have a nice evening.
Auf Wiedersehen und alles Gute.
Ja, auf Wiedersehen. Bye.